Alright, hello my people. Hope we're doing well. This is video 2 on the vocab and properties for our calculus readiness review unit. Let's just go ahead and jump right in. Now this isn't an exhaustive list of properties, but these are the ones that we'll usually refer to. Now notice that on here is the distributive property is not on here. I expect that you already know that one. Because it winds up being mentioned a whole lot more than all of the others. Notice that the transitive property is also not on here, largely because it's more of a logical one, and it just doesn't really come up in conversation. As I've said before, I'll never give you busy work just for the sake of giving you busy work. If I have put a definition on this list, it's because it's one that you need to know. If it's not on this list, it's because I find it to be sort of additional, supplementary, maybe even superfluous, and therefore I'm not going to ask you to memorize it. I will never give you more work than I feel is necessary, but these are the things that are necessary for you to know. Okay. So let's go ahead and get to it. The commutative property. Now remember, this is commutative, not communative. Numbers don't commune, like they don't wear tie-dye shirts and hang out, and talk that hippie speak and smell of patchouli. They commute, okay? They move. And so basically you have two commutative properties. You have one of addition, and that additive commutative property is A plus B is equal to B plus A. Commutative property basically means that for addition and multiplication, it can be done in any order. So 2 plus 3 is equal to 3 plus 2. But it can't be done for subtraction, right? 2 minus 3 is not equal to 3 minus 2. In fact, they're opposites of each other, or negatives of each other. So the commutative property of multiplication is A times B is equal to B times A. Okay, and that's all. If I asked you for the commutative property of addition, you would just write that. If I asked you for the commutative property of multiplication, you would just write that. Now, if it were flipped around and I gave you this expression right here on the bottom and said, what property does this represent? You would not need to only give me commutative property. You would have to give me the commutative property of multiplication. Okay. Now remember that these kind of come in pairs. These two belong together and these two belong together. The associative property is kind of a corollary of the commutative property because it's based upon the same principle. And because the associative property has to do with how you associate or group certain terms or factors. And if I have A plus B plus C is equal to A plus B plus C, the reason that those are equal to each other is obviously almost the same as the commutative property, because if I have three terms and they are grouped differently, the grouping changes the order of operations and therefore changes the order, right? And basically it's a matter of if it's all addition and the order doesn't matter, then neither does the grouping, neither does the association that you're making between certain terms, okay? The same is true for multiplication. By associating different factors, you are basically changing the order of the multiplication. So again, it's if the order of multiplication doesn't matter, then the association, the grouping of particular factors doesn't matter either. So let's move on to the identity properties, okay? Now the identity properties, and I jumped up and down and ranted and raved about this in class, most students believe that these are absolutely pointless to learn, right? The identity property of addition is basically says A plus 0 is equal to A. So it's kind of what must I add to A in order to get A. But these actually wind up being important principles for us even the multiplication one, which is, what must I multiply by to keep my value of A, adding 0 and multiplying by 1 are two of the most powerful things you can do in mathematics. Now, 0 doesn't always look like 0, and 1 doesn't always look like 1. But, like when you're multiplying something by the conjugate over itself, you are multiplying by 1. You're just multiplying by 1 in a really creative and strategic way, but it's still 1, and since it's 1, this is the property that ensures that that product will not change the value. Now, the identity property, when we pick it up and use it strategically, we don't do it as often as we do it for addition, okay? But it does happen, and we talked about an example or two of that in class. Now, the inverse property is a way of it basically restating the identity property, so it's kind of a corollary of the identity property. The addition, the inverse property of addition, is basically says a plus negative a is equal to 0, and the inverse property of multiplication is a times 1 over a is equal to 1. So you can kind of see how these are related to each other. This is basically a reordering of the terms. It's basically using that equation and mixing it up a little bit. And the same thing for the multiplication, inverse property of multiplication to the identity property of multiplication. So you can kind of see the logic that is similar there. Now, more important than the inverse properties is the general principle of the inverse. Okay, now inverses, it's a pet peeve of mine for people to say, well, it's the opposite. Okay, well, what's the opposite of 2? And most people would say negative 2. Yeah, sure. But 1/2 is also the opposite. So, and so when you kind of get into, when you start calling it the opposite, it just lacks a little bit of precision. So if you weren't talking about the inverse, you were just talking about its opposite, then when you're talking about perpendicular slope of two linear functions, it's not the negative reciprocal, it's the opposite slope, right? And it just lacks specificity. But for our purposes, and some of these words I'm going to define in a very specific way because I'm trying to drive a specific thing home. What I want you to memorize as the definition of an inverse is that which undoes. Okay, addition and subtraction are operational inverses because they undo each other. Okay, and that's also why they're secretly the same operation, just in different directions, right? One drives you to the right up the number line, and one drives you left down the number line. Multiplication and division, operational inverses. That's why they're secretly the same thing, right? One gives you like an order of magnitude larger, one gives you an order of magnitude smaller. Exponents and radicals undo each other. That's because they're secretly the same thing. That's why radicals can be represented as fractional exponents, right? And the thing is that what's great about this is they undo each other. But this even holds for when we actually get to functions and talk about function inverses. What does a function do? Well, it's doing things to the variable. Well, what does its function inverse do? Well, its function inverse undoes everything that the original function did to the variable. That's why when you take the composition of those two functions, all you're left with is the variable, x, right? And if you don't understand that, we can talk about it another time, but that which undoes, okay? Inverses undo other things. Now, the reciprocal, of course, is just one of those things. It is the multiplicative inverse. And the last thing we want to talk about on this particular one is the multiplicative property of 0. And I say a times 0 is equal to 0. And you're like, wow, that's just as earth-shattering as the identity properties. And you're like, well, it actually is pretty important because this is the principle that we use when we're factoring to solve. right? And we talked about this a little bit in class. When we're factoring to solve, the multiplicative property is 0. It's not that it's anything times 0 is 0. It's the only way for a product to be 0 is for one of its factors to be 0. And that's why we gather everything, like when we're solving a quadratic by factoring or a polynomial by factoring, we gather everything onto one side and set it equal to 0. Because if we set it equal to 0 and then we can get it into factored form, we have a product equal to 0. Well, when is a product equal to 0? When one of its factors is. Okay? There is no multiplicative property of 2, right? Because if a product is equal to 2, there's really no necessity to the value of any one of those factors. But if a product is equal to 0, there is a necessity that at least one of the factors is equal to 0, because a product can only be 0 if one of its factors is. So that kind of brings us to the end of video 2, talking about properties. We'll talk about, in the next, I think it's going to be about 3 more videos, we'll talk about more of the vocab. Of course, like usual, I'm going to go ahead and scan these lecture pages or these video pages and post them with the playlist to these videos so that you'll have those for reference for later. Okay? As always, if you have a question, shoot me an email and I will answer it. Bye.